Welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue learning about robustness in regression. And in previous video we looked at the intuition behind these three algorithms: RANSAC, TheilSenRegressor, and HuberRegressor. In this video we'll look at the actual implementation in Scikit-learn in Python. So let's get into Jupyter notebook and see how we can code these. Here I've imported these libraries, which includes make pipeline and polynomial features that we'll be using, and these are the versions that I have installed. Now for data sets, we'll create a data set using make regression, and to that, after the data set is created, we'll add some noise to it so we can test the algorithms and see how they work. I'll get started with creating random seed of 0, and then x comma y is equal to data sets dot make underscore regression, and here we can specify n underscore samples is equal to 500, n underscore features is equal to 1, noise is equal to saying adding 20 noise, and then random underscore state is equal to 0. So this we can print the shape of these, so x dot shape, and then we have x dot shape. Similarly we can print the shape of y, so y dot shape, and we have shape right here. So we have around 500 records. Now the first item we need is the number of outlier data points, so I'm setting it to 50. And now what we can do is use the x that we created up above and change the first 50 rows of those to a different value. So this is arbitrary. You can add any value here. So I'm going to add, shifting it by 3 and then adding 0.05 into np.random.normal, and here specifying the size as num out and comma 1. That's for x. And then for y, again we need a similar set, so we have the first 50 data points, and then adding -3 here, plus adding 50 this time into np.random.normal, and then this would be size is equal to num underscore out. So with that, the one last thing that we want to do is separate these out into outliers and inliers, so we can plot them with different colors. So the x underscore, so this would be x and going up to num underscore out, and then y underscore outlier would go again up to num underscore out. Similar to this, we have the inliers, so x underscore inlier is equal to x, and this would start from num underscore out and proceed to the end of the array. And then we have y underscore inlier is equal to y num underscore out, and so on. Finally we can plot this, so plt.scatter. Let's plot the inliers first. Inlier y underscore inlier, and we can specify alpha is equal to 0.2, just so the dots, if they overlay, there is some transparency there. And then we can plot the outliers as well, so x underscore outlier, y underscore outlier, and here we have, again we can set the alpha to, let's say, 0.2, and we can now show the plt.show, and so we have an error, np.random.normal, and was missing a L there. Okay, so that's the data set we have, and as you can see, in addition to the blue data points of interest, we have these orange data points, which are uh, the noise in the data set. So how can we work with this data set? So one thing we can do is, first we can try linear regressor and see how that fits. So reg is equal to linear underscore model dot linear regressor, and if we do a reg dot fit on, so we can do the fit on x and y, and then once we have that, we can then uh, create, let's create x test, and let me create that up here. So x underscore test would be the same as the x that we have in linspace. We'll keep it the same range as well. So np.min, so minimum value of x, and then maximum value of x. We can decide how many points we want. So let's say we have we get 10 data points. So comma 10 data points, and this we also need to reshape this, so -1 and 1. So that's our x test, and based on this we can now predict. So y underscore pred is equal to this would be reg dot predict, and this will predict on the test, or we could call it plot. It was not actually test. I'm gonna call it x plot, and this would be y plot. So with that, once we have those values, we can now plot them on the same plot that we have up above. So what I'm going to do here is copy this text, and this is the original, that's the original plot, and then on top of that plot we are going to add this plot for linear regressor. So let's copy that, put that here, and here we can say plt dot plot, uh, and this would be x plot and y underscore plot, and line style you can change that if we wanted to let's say a dotted line. And when we run this plt dot show, we get an error. Let's see what the linear regression. Okay, x plot, so we run that. Okay, so as you can see, regression does not do a good job in uh, performing the fit, and the line is, it's off from the blue dots, and it's, and because it's considering the orange dots in the fit. Now let's use the exact same code and change the algorithm that we are going to use now. So this is for RANSAC, RANSAC regressor. So with this, we should get a different fit, and I'm going to leave the names of the variables as is, because it shouldn't matter as it will override. And this could be, let's label this, so label, this is linear regression, or yep, like that. And then this could be, this is ransac regressor, and we can name, get it a different color, let's say orange color, and run this and see what output we get. So as you can see, the ransac does pretty good job in ignoring the outliers, and that's the very good example of robustness. So plt.legend, and we have the legends as well. Now in addition to this, we can go ahead and, while we are at it, why not run the other two as well. So the next one is TheilSenRegressor, regressor, and copy that, paste it here, and paste it again here. And the color, this could be red, The red is already there, so maybe a green color. And then the next one is HuberRegressor. So I'm gonna copy that, paste it here, and let's call this gray. When we run all these three plots, as you can see in the magnified view, the orange is the ransac, and it's the least affected in this particular case. The other, the followed by that, TheilSenRegressor is also doing a pretty good job, as the HuberRegressor does move a little away from the actual blue data points of interest, but it's all the three are pretty good than the simple linear regression. And if you optimize the parameters for those three, I'm sure that they'll line up pretty good to the blue data points or the inliers in the data set. Now next, let's look at, this was linear, the data set was linear, and we had this position of the orange dots. Those could also be changed, so let me go ahead and try one option. So right now this is at 50. So what I can do is maybe flip this, so change this to 5, maybe change this to 0.5, and run this again. And as you can see, this did change. And if we run this again, so here you can see the fit has now changed because we have these outliers uh, in a different position. And in spite of all these outliers, we can still see that the ransac and TheilSen are right on where the blue data points are, and they seem to be the most robust in this particular example. Now moving on, let's look at a sinusoidal data set. So I'm going to label this as sine, and for this we'll create a data set and label those x's as x in for inliers. We have np.linspace, and we'll go from 0 to 10 and create 100 data points, and then reshape this, so -1 1. And similar to this, we need y values, so y in would be just the sine values of this, so x in, and I'll go ahead and reshape this as well to -1. So with that, now we can create a bunch of outliers. So the very first one that, so let's call this outlier number 1. So here we'll add error to x error is equal to first creating the copy of x, and then x underscore error. So here what we'll do is every third data point in the data set, we'll set it to a value of 6. And then we have outlier second. This, by the way, we could plot this, so we have some visual intuition of what we are working with. So let me go ahead and plot this. So that's what we are working with. So these are the x's go from 0 to 10, y goes from +1 to -1, and it's within this that we are changing the values. The second is y, and we'll change the value of y. So for this, we'll copy the value of y, and then we have y error. This, for this, we'll change within the first 30 records. We'll set every third record to the value of 0.50, and then outlier number 3. This would be a large error, and for large error we can again create copy of y, and then for large error here I'm going to uh, increase the value of the value that we are substituting there. So for the same first 30 records, instead of 0.5, this time I'm gonna put 5, so it'll move much farther away from existing y values, the inliers. Outlier number 4. So for this, we'll shift the values of x to by a large margin. So x in dot copy and x underscore large underscore error, and for this again alternate t, every third data point we'll set it to a value of 15. So those are all the values, and then when we do the prediction we need something for x, so we'll create another variable x plot as we did before, and that would just be simply a copy of the x in that we have up above. So with that done, now we can create a bunch of estimators. So estimators, and so we'll create a list. So estimators is equal to, now within this list we'll create tuples. So tuples would have, was the title, linear regressor regression, and the reason why we are doing it this way is to speed up the process when we do multiple reruns. Linear regression, and so that's there. This is also a good practice. And RANSACRegressor, and again this would be linear underscore model. I'm going to copy this linear model so you don't have to type it every time. RANSACRegressor, and then after this we have the TheilSen, TheilSen regressor, and this would be again TheilSenRegressor, and finally we have the HuberRegressor. So HuberRegressor, and again HuberRegressor. So with all those estimators in line, now we can create a for loop that will iterate through each of these estimators and give us the plots. So for this is the outer for loop, and then we'll have an inner for loop as well that will run through the outliers that we created above. So the first one, we have for title, and this underscore x, this underscore y. You'll see that this code lines up with what examples in the doc. So if you want to, you can also refer to the code in the docs as well. So here I'm going to create another list, and this would be list of tuples that has the titles that will use in creating the plots. So modeling errors only, and that's because this would be the base value for inliers, and x in, y in. Then the next one is small errors for x, so small x errors, and so here we have x error, and then y would be good, and then we have small y errors, so small y error, and the x values in this case would be all inliers. However, the y would be the error values that we created above. Moving on, then we have the large values, so large x error, and for this x underscore large underscore error, and then we have the normal values for y, and finally we have the large values for y error, and here the x values would be the normal values, and then we have the large values for the error. So that's going to be our for loop. So we have a colon here. Now we could add tab here, move it a little bit. So here let's go ahead and create a figure now. So going to use fig is equal to plt dot figure, fig size is equal to create a 5 by 4 figure, and to this then we can add uh, our original plot. So plt dot scatter, and this would be using this underscore x, this underscore y. Before that we can add the actually this data point, this data set would have all the values, so we need not worry about plotting the outliers and inliers separately with different colors. Here we have plt dot scatter with this, and we can add a marker to this. So let's add a plus sign and color this to bright blue. And for now we are going to iterate through the estimator. So that was for the data set, and for estimators we'll go through name and have the estimator, because here we have a tuple with a name first and then we have the actual name of the estimator. In estimators, and create a model is equal to make underscore pipeline, and the first one is polynomial features, and this would be 4, that's the degree of 4, and we have the estimator. So and now go ahead and fit this. So this would be fit on this underscore x and this underscore y, which has the outliers. And finally we can plot this. Y underscore plot is equal to model dot predict x underscore plot, and sorry, didn't mean to run the cell yet. So plt dot plot x underscore plot y underscore plot, and then line style you can change this to a dotted line, and add labels. So labels we can have them show up as the legends besides the plot. Title is equal to, this would be just the title, and after it is iterates through each, after each iteration, after the for loop is completed, we can plot, we can ask to show the overlay. So plt dot show, and this is done. Going to add a line here that suggests that the loop is done for that data set. So now when we run this, here we can see the fit. So this is really beautiful plots, and here this is the original inlier. So as you would expect, they fit really reasonably well. And now comes the fun part. So here as you can see, this is outlier here, and even though even in presence of the outlier, the data and the uh, algorithms, they do a pretty good job in fitting these regressors onto the data set. Now here as you can see, these are the outliers at 0.5 that we created for the y error, and as you can see, these dotted lines fit really nicely along these uh, plus signs, the blue plus signs, which is the original data, and it ignores these uh, uh, y outliers that are there. Similarly, now in case of large values for the outliers, so here we have the value of x that's at 15, and still we can see that the fit is not as good as above, but it still is within the zone for the actual data set. And if we tune the knobs around these regressors, we could get a even better fit. So what we have run this right now is on default setting. And finally, for large y error, it's doing a pretty good job at fitting on the actual inliers and ignoring the outliers. So that was it for this video. I hope in this video you learned the actual implementation of RANSAC, TheilSenRegressor, and HuberRegressors um, with a data set that has small outliers or large outliers both in x and y directions, or when the data set is linear or the data set is non-linear. So this is a very powerful technique, and I hope you are able to do some trial runs on data sets that you may have. You could introduce some outliers in there and see how these regressors perform on your data set as well. If you have any comments or suggestions, please let me know in the comment section below. I hope to see you all in the next video. Until then, please like, share, and subscribe. Thank you.